Hello guys, welcome to our vlog Arrow Beast. In this lecture we will discuss about Zeroth law of thermodynamics. So Zeroth law of thermodynamics, it gives the concept of temperature. So Zeroth law of thermodynamics gives the concept of temperature. So if a body A is equilibrium with the body B and the body B is equilibrium with the body C, then the body A is equilibrium with the body C. So this is the zeroth law of thermodynamics. It gives the concept of temperature. Okay, so going with the first law. First law of thermodynamics. So first law of thermodynamics, it gives the concept of internal energy. It gives the concept of internal energy. What do you mean by internal energy? So internal energy is the sum of potential energy and the kinetic energy. So first law of thermodynamics gives the concept of internal energy. So perfect definition is that the first law states that when a closed system undergoes a thermodynamic cycle, then the net heat transfer, which is denoted by Q, is equals to the net work transfer. So this one work is denoted by W, that is integration of dq is equals to integration of dw. So the first law is also known as conservation of energy. So the first law is also known as the law of conservation of energy. Means energy can neither be created nor be destroyed. So going with the second law of thermodynamics. Second law of thermodynamics. So the second law gives the concept of gives the concept of entropy. What do you mean by entropy? So, entropy. So, entropy, it is used to measure the randomness or disorderness in a system. So, second law of thermodynamics gives the concept of entropy. So what do you mean by entropy? We are discussing about the entropy. Entropy is used to measure the randomness or disorderness in a system. So the second law of thermodynamics can be defined in two different ways according to the Kelvin, Planck's and clauses as follow. So going with the first Kelvin, Planck statement. Kelvin-Planck statement. So, Kelvin-Planck statement. According to Kelvin-Planck statement, it is impossible to construct an engine working in a cyclic process whose sole purpose is to convert heat energy from a single thermal reversal into an equivalent amount of work. So, in simple words, there cannot be an engine that can work in a cyclic process converting all the heat supplied to it into mechanical work. This one is a Kelvin-Planck statement. So second one is Clauses statement. So according to Clauses, it is impossible for a self-acting machine working in a cyclic process to transfer heat from a body at a lower temperature to a body at a higher temperature without the aid of external agency. So in simple words, heat cannot flow naturally. Heat cannot flow naturally from a cold body to a hot body without the help of work input. So this is the Clauses statement. So next one is third law of thermodynamics. So the third law of thermodynamics states that the entropy of a pure substance in a thermodynamic equilibrium approaches zero as the temperature approaches zero. So mathematically limit as T approaches to 0 is equals to 0, where S is the entropy and T is the absolute temperature. So this is the third law of thermodynamics. In the next video, we will discuss about the work equation for various process. So I hope you like this video and do subscribe my channel. I'll bring more notes in the next video. So thank you.